I'm going to talk about basically the vegetation map and the various conservation elements that we derive from it. And please just pipe up anytime as I'm going along. But so we in order to even look at conservation elements or the vegetation classes that we wanted to evaluate for the YKL, REA, that's a lot of acronyms there. We had molded together a map, and I talked about this some yesterday. And but these are the data sources, and the blue all came from those old, not old, but the Ducks Unlimited and BLM maps that were put together. And then the other dominant source of these land cover maps is actually Landfire. And this one doesn't have particularly that good of the red, the Landfire, and it doesn't particularly have that good of accuracy assessments, probably around 40%, whereas the BLM map, actually I have some numbers here in a second, but so anyway, we put together a map, and that's the map. And so the AMT expressed concern over the accuracy of the land cover map, and so we went ahead and evaluated it. I should say Monica did this component of it, and also McGee helped out tremendously in this. I should have acknowledged people, and Tim helped out on this project, and Jamie, of course. But so we looked at the accuracy of the various maps that comprise our map, and it ranged from 62 to 94%. Now, some of these maps have a range of accuracy too for the land cover classes. That's not what this is. This is the overall accuracy per map. So from 62 to 94%. This seems a little confusing, but one map, we had one map with real low accuracy, but it reported a range of 33 to 85% for all the different land cover classes. And then 17% of the total area did not report an accuracy for their maps, and that was basically the Park Service maps. And I actually did the Denali map, but they would use all of their training points for developing their land cover map. They wouldn't save any of them for looking at the accuracy of the map. But in general, I think the Park Service maps are probably just as good as the BLM Ducks Unlimited maps. So all in all, they're good maps. They're maps that were developed with standard methodology. There's a lot of work put into them, a lot of field work, and a lot of spatial analysis time was put into it. And the only one that, like I said, the only one that has a poor accuracy is the Landfire map, and we're trying to replace those. And I think it's around 40% accuracy of the Landfire map for this part of the state.
But just to make sure I understand, that was not, you didn't conduct an accuracy assessment, you just listed the accuracy assessment that was reported with the data set, is that correct?
That is correct.
Okay.
Monica, did you want to add to that? Or?
I can say that originally we had intended to kind of look at accuracy on a map class by map class or a CE by CE basis, and we tried to see if we could pull that out, because in some accuracy assessments they actually look at per class so that we could get a range of accuracy per class. But because accuracy assessments weren't done consistently between each map, and because in some cases there were multiple images used, and in a single map there was multiple accuracy assessments done for each class, it got really convoluted. And so instead of reporting it by class basis, we decided it would be a better metric to use just to get a kind of an overall sense of the accuracy of a map in and of itself. And if the next step would be is if we did have funding, and it would be great to do an accuracy assessment of the map itself, but that would require taking independent data points, basically, accuracy assessment on the mosaicing process, which is different than kind of looking at an individual map. So,
I'll say too, on accuracy assessments, these accuracy assessments they've reported in these individual projects are corresponding to actually finer ecological classifications than what we're presenting on for the conservation elements. So keep that in mind, that these classification accuracies represent finer scale ecological classifications. And so we've amalgamated them up into these broader categories, and so we're likely increasing the accuracy. I mean, in an ecological sense, we're increasing the accuracy because we're taking these similar classes and putting them together. So I would just say keep that in mind as we're going through, even with the land fire being as low accuracy as it is. You know, we've boiled it up into these larger classes, and so that it makes more ecological sense, and it should hopefully help with our understanding of the accuracy, overall accuracy of this map.
I can add to that. So I've used this mosaic in another part of the state and compared it with observer recorded habitat classifications at particular points. And I can say that the mosaic, at least this Alaska Peninsula, was highly correlated with the points or the habitat classifications of each point, but only when you condense them down into the major classes. So that did help quite a bit.
Good. Glad this thing is useful.
I just want to make one comment about the duck limited data because I've heavily involved with this for a number of years. And in this region, I think there's probably, I don't know, I have to go back and look, 3 or 4 different projects that were done at different times. Each of those projects had an accuracy assessment done for them. And most of them, I can't speak specifically, but most of them were ranged anywhere from around 70% to 80s as far as the overall project map accuracies. But within each project, there was also accuracies done for each specific classification. And some of these varied widely, mainly because some classes didn't show up in that project at a very high level. So there's very few points, which means the accuracies wouldn't get a quality accuracy on that, as opposed to open needle leaf, which was spread widely through a number of these projects, had a lot of points or sites selected or collected during the process, so those accuracies are very high. So within each project, the accuracies on a specific classification might vary, but there is an overall accuracies for each of the projects. So.
And we have a table in the document for that too. And but the good thing about the DU-BLM maps is that they use the same classification for every single one of the maps. And so it was really the mosaic various ones together because they had the exact same legend. And just one more thing about accuracy assessment. The main problem with the land fire map was that they tried to map floodplains, and it wreaked havoc on the accuracy of the map, because they were almost 90% wrong on where they mapped floodplains. And so what we did was we had Megumi digitize floodplains, and I'll get to that in just a minute for the entire area. And what else? What was it? Anyway, as the other driving force for understanding where floodplains are.
There's another aspect of the land fire statewide map is the folks that developed it weren't here, have no experience within the state. They were just using data that they had. And so invariably, when a question would arise about, a class, is this correct or not, they didn't have any background to make a correction.
Yep.
and you can see, Keith has been mentioning kind of accuracy assessment figures for land fire, and we have stated that there's no accuracy assessment, so that might be a little bit confusing. There's kind of some internal work we've done to try to...
They did one, they finally did one, and they just published it a few months ago, and I haven't really...
Oh, okay, so maybe we should update that in our report.
What?
Land fire did an accuracy assessment?
Yeah.
Okay.
I think you can get it off the web. I haven't looked at it.
Okay, anyways, we could update those figures.
But, up until a few months ago, that was true, but, they have an accuracy assessment for the map.
Okay, great.
Well, at the end of this, I'm hoping we'll talk about this more, because I want to bring up about what happens when better data comes in, and can we apply it to the model? Because I expect that with better imagery, you know, with this whole SDMI program, that will hopefully have higher res and good accuracy assessed, land cover data in the future, and not have to stick with what we have, and, you know, including, even though the Ducks Unlimited, land cover is good, it's still 30-meter resolution.
And the last bullet in this is a recommendation that we develop a new land cover map from, the new spotting group,
So, yesterday, is Nancy on? Nancy, are you on? Shoot. Yesterday, we talked about the alfresco model only being run on the forested part of the landscape. So what, vegetation communities does that correspond to, that alfresco is run on and not run on?
we know. Deciduous forest, and then the white spruce and black spruce, forest.
So none of the, shrubby stuff?
None of the shrubs.
Okay. So she said, I thought she said something like 80% of the landscape was run, but if you add up 43 and 16, you don't get to 80%.
Nope.
So,
Yeah.
different map.
They use, I'm not even sure.
Use an LCD.
An LCD, yeah, which is actually a pretty good map, you know, of the extent of forests, but, that is quite a discrepancy.
That's, yeah,
Well, I
that's
think
a
they,
big difference.
I think they assign a pixel to the dominant, like if it has forest, they assign it to forest, so they don't get at it as a.
So it's a
by
kilometer
scale.
wide, yeah.
Right, it's at a coarser scale, and so I think it's.
And this is a 30-meter pixel? This?
So much by 30,
That would make it huge difference, you know.
Yeah.
Okay.
Now, the NLCD is actually, I think, 30 pixel resolution.
It is in its native form, yeah.
Yeah.
But alfresco, it
It rolls it up to.
it rolls it up, yeah.
And then if it has any tree component at all, it's treated like it's forest?
I don't.
Majority
I think
Majority.
but I don't know any of it.
I don't know what the threshold is.
That's still, that's a surprisingly large difference, though.
It's a 12 or 14 class.
NLCD is,
So there's only like 14 classes as opposed to 30 for most of the other work, so they're very generalized groups, classes.
Right.
Yeah. Okay, so, our jargon terrestrial coarse filter CEs are deciduous forest, dwarf shrub. We designated, we delineated, or we delineated floodplains, for us, and that's actually a biophysical setting. It's basically a successional unit. We have herbaceous wetlands, low shrub, which is, things like Betcheliana, Ledum recumbens. And then tall shrub, which are mostly the taller willows and alder. That was primarily, it's probably mostly alder. And then white spruce or black spruce. Yes?
I remember, when we talked about how you were gonna lump this at one of our meetings last year, or whenever the heck it was, there was a lot of discussion about trying to break out white and black spruce to try to get at, biomass opportunities.
Yeah.
Better. And I remember we kind of thought we couldn't, but can you remind us of what why we can't, was it a problem with the entire, area, or is it because some of the maps weren't accurate enough, or why could we not split out white and black spruce?
Well, Scott might be able to answer that better.
We talked about this
Just
yesterday.
yesterday.
When we were in the field, for instance, on a Ducks Unlimited project, and viewing, spruce forest, we try to split it as far as black spruce and white spruce by appearance. Meaning the low, stunted, bended, wet areas we characterize as black spruce, the riverine, tall, robust, up to 50, 60 meter tall, spruce we characterize as white spruce. Now the problem is the lower sloping hill areas look like white spruce, but if you're actually on the ground, because we did a lot of ground truthing with that, and also with NRCS and other projects, these are often mixed black and white spruce, although you can't tell it by the growth form. So we would generally select just spruce as the class, or write it down as as white spruce if it appeared that way, or black spruce if it appeared that way. There's no way spectrally to split these two out using a spectral signature that we would get from actually the satellite image. So that's the problem with this issue, is that we can't identify it remotely. More than anything, we can't identify general groups as a whole,
Yeah, we
but
might.
you can only identify it really on the ground. So that's the problem with splitting it out in spectral format.
Yes.
Do you, in the document, define what DU veg types, you've grouped into each of these?
Yes. Yeah. All the other maps, I think there's only one map that broke out black spruce from white spruce. And all the others ended up lumping them together into a white spruce or black spruce, because they have the same problem that BLM and DU had. That includes myself. I mean, I mapped Denali Park, which is the only map that's in here that I was on the ground for, and we couldn't do it with the Landsat imagery either. Yeah, and the white spruce and black spruce class, for example, includes woodland white spruce or black spruce, closed white spruce or black spruce, because those they were able to map, and then open white spruce and black spruce. And but just to address this, and this is actually going to come up a little bit later in the document, was how to model certain white spruce. If we had, once this new DEM is developed, we should be able to improve the accuracy of white and black dramatically. Because the white spruce, like Scott was saying, is generally down on the floodplain. The black spruce is on the flat, wet areas and on north-facing slopes. White spruce is on east and west and south-facing slopes. So it's those patterns generally hold up all through the interior for us. And if we had a good DEM, which we don't right now, we could map that, and that's supposed to be that's coming down the road. Not sure when.
Let me just remind folks to put their phone on mute. We can hear some rustling going on out there as I'm looking at the ceiling where the speakers are. Thank you. Sorry, Pat.
Yeah.
Do you think improved soil surveying, more detailed soil data would help to distinguish between the two also?
Oh, yeah. Absolutely. That's one of the recommendations, too, is to either put together an NRCS soil survey, which is real expensive, or use an eco-type approach, which is what the Park Service started to use, which is they just map soil at a coarser level.
And there's an opportunity too with the new spot imagery, Landsat 30-meter pixels, that gets that mixed spruce types. 15-meter or even pan-sharpened down to 5-meter kind of pixels, we might be able to split out the spectral difference between white and black spruce, or at least the underlying soil characteristics that would help us train it up. So with new data, there's going to be more opportunity to try to map these classes more accurately. It has huge ramifications for the alfresco fire models and a lot of other kind of ecosystem dynamics. So it's an important data gap that we should all kind of be moving forward addressing.
I'll just add quickly, and alfresco actually tries to separate white and black spruce, so they do have a mathematical model to do that. We've never actually, it's theoretical.
You can't put it up on the screen.
We've never been able, I don't know if it's one, but we've never seen it, but anyways, that is incorporated into their model, but obviously if we had, better maps.
Spatial output that we can use.
Right.
One other one besides white versus black spruce is willow versus alder.
Yeah,
We had a wildlife
I was
biologist
gonna bring that up,
who wanted so dearly years ago to be able to separate out the willow so he could have a better moose habitat area.
And I was just gonna ask Keith to go back to that slide, and that, since we were talking about splits, that's one that we've run across with a number of managers for that reason exactly, that if we could split the alder versus willow, that would be hugely beneficial, and I don't know what the implications of doing that are.
Some of the maps do, and some don't. And it just depended on sometimes the imagery that they had. If it's taken later in the year, the willow tends to senesce much earlier than the alder. So then it jumps out at you. But other times, they look the same. In July when you're out on a site, it's hard to tell the alder from the willow when you're in the air or spectrally. And Tracy will be covering, we did develop a willow map.
I'm
for
not
the
going
area.
into much detail.
What?
I'm not going into much detail.
Okay. So we took our best shot at it, and, splitting out alder from the willow. And, that was modeled, and again, Tracy will be dealing with that. Now, these various conservation elements that we have, the only one that is really impacted by anthropogenic use to any large degree are the floodplains. And so what I'm going to do here is just talk about, go into a little bit of depth into the floodplains, and plus this is the only one we had a lot of information on, and we could go into any kind of depth. And so we talk about this, we just call it the large floodplain conservation element. And basically these are all the low elevation, large floodplains, Kuskokwim River, the Yukon River, and various other ones. And I think the maximum width we mapped was a half mile, was it? I have to go back to the map there, but,
You remember Magumi? Yeah. It was pretty big.
It was pretty big, but you look at it, it covers a lot of the area. And the other reason we mapped, floodplains was we wanted to know where the willow was and the moose habitat. That was another driving factor in this, because, moose like floodplains, because they like to eat the, early seral willows, and then also the, balsam poplar. They eat huge amounts down in the floodplain. So we went ahead and mapped the floodplains, and these are just areas that, this includes, when we map the floodplain, it includes the river and the bare ground and all the different successional units, or land cover classes in there, and also successional units. I'll get into succession in a minute. It covers 8% of the study area, which is, quite a bit. And we found that there were actually two types of floodplains. One, in the colder northern part, and this is based on vegetation and succession physical processes that control the floodplains. One's the colder interior area where there's actually permafrost, and on the ancient floodplains, the older floodplains, terraces, and then the warmer southern floodplains to the south that do not have permafrost on the ancient terraces. But there was also a distinct difference in species. And I'll get into that in just a second. But for each of these conservation elements, we also provide a conceptual model. This is just to give you a general framework of how the change agents can affect the different components of the floodplain conservation element. I won't go into any detail here, so don't start reading it, but I'll go to the next one. So anyway.
Hey, Keith, before you go any further, this is Cindy up in Fairbanks. Can I just ask exactly what these floodplains were digitized from? Is this, you've started with the NHD and then looked at the veg classes outward from that, or is it just water classes from the veg and then started from there, or was it DEM as well, or?
First, we started with the Statsco had drawn some of the floodplains for the area, the NRCS soil map, and so we used that as a basis. We also then we pulled up NWI to see what they mapped in the area, and they had mapped certain parts of the area, but it was just real discrete areas. And so then we grabbed the Landsat imagery for the area.
Or better, right?
Or better.
Yeah, we used the
Google.
GINA best available data set layer, imagery data set layer. So in some regions that got down to aerial photography that were higher resolution than Landsat. At worst, it was Landsat. But in some areas, it was really high resolution imagery that allowed us to kind of differentiate that active floodplain.
And when we used the high imagery, the really good imagery, we tended to redraw the Statsco lines because we just had better data to work with. Sorry.
Oh, well, that kind of answers that question. So, and you were using the imagery, just visually looking at true color imagery and not trying to...
No.
Okay.
Yeah, we're
No.
just doing heads-up digitizing.
Yep.
It makes a huge difference, the better imagery versus the Landsat.
Well, manual interpretation.
Yeah.
Just goes well beyond spectral and mixing, in these kind of applications.
But the results are, some of the area we did not have the really fine resolution imagery. In other areas, we did. And so we just did the best we could with the imagery that we had, and it was the very latest information available.
How does this overlap with riparian, data-wise? Do you think that you can, if you, I guess, were confident with your floodplain data, could you derive a riparian area from it, or?
That's actually what we did. I think you're getting at Willow, right?
That's kind of what we did.
Willow.
Well, and just a general riparian,
Riparian zone, kind of, yeah.
Yeah, so we took the hydrography layer and buffered it. I think this is how we came up with the Willow map. And so and Trace will be showing that later on, but we took all the streams and just said, okay, well, these streams probably have Willow next to them, someplace or other. So we buffered them by a pixel or so on either side and said this is potential Willow habitat throughout the REA. And so that was one of the ways we got at Willow.
You the larger streams, not the smallest.
Right, so for the large rivers, we use the floodplains where we heads-up digitize them all, using the StatsGo map where there's a bunch of classes that are labeled floodplains if you're familiar with the soils mapping effort. Some of them are really old, so it doesn't really translate to what you think of as kind of an active floodplain. So we basically took those classes, took pieces of polygons, so we didn't just kind of select an individual polygon as being floodplain. So we had to kind of go in and decide which classes made sense to use as floodplains. So then after that, McGinney went in, and if it wasn't drawn well based on the best imagery we had, she went and actually redrew the floodplain. So it does kind of get at the active channel and then the riparian corridor. I mean, you know that these rivers move around a ton, so those floodplains, the riparian corridor that you're looking for might be hard to kind of pinpoint at any particular time, but based on that current imagery, it's probably a pretty good estimate of where the riparian corridor is for the region. But then in addition to that, he said for trying to look at specifically willows for smaller streams, we pulled out NHD and basically just took all of the small streams of a certain length, and then took those and just buffered the small streams because they're kind of a single line to get at that riparian corridor. So that's not, taking into account where the actual corridor is, just kind of a modeled approximation of what a floodplain would be. And that's where we assumed it would be pretty small, but, at the resolution of our imagery, you still have to kind of buffer out a fair bit.
And then
We have two different ways to get a floodplain.
And then you laid that on top of the vegetation map, right, where you extracted all the...
We did, but because of the resolution of our vegetation map, it didn't make sense to look at the veg classes that underline the buffered polygons.
Yeah. I'm surprised though, when I looked at the little streams that are up in the mountains, a lot of times, well, if there was a tall shrub up there, up in the alpine, and there were some tall shrubs, it was usually correlated with the stream. So they had mapped the pixels correctly. The resolution was sometimes a pixel off or whatever, but they had mapped the tall shrub willow up in the alpine zone anyway, accurately, fairly often. And so we've tried to tackle getting at willow for this project. And again, Tracy will show you that, but those are the methods we use, and I don't have the slide here. Tracy keeps showing it. There are differences between the southern floodplains, the ones without permafrost, and the northern floodplains, the ones in the interior. I won't go into much detail, but basically, the areas with permafrost, the ancient floodplains have a lot of thermokarst lakes and, I don't know what you want to call them, distorted, those sloughs that get all distorted with ice buildup in the soil. And, but also the late seral species tend to be black spruce. And in the southern part of the state, where you lose the permafrost, you also lose the thermokarst lakes. The late seral tends to be white spruce. And also you have a lot of kenai birch. That's the dominant deciduous species in the southern part of the REA. And here's just an example of these thermokarst lakes. You can see them through here. And this is the areas with, the floodplains with thermokarst and permafrost on them. And you see these little lakes here and there, just pockmarked across here. And you go south on this map on the lower part, and you don't really have those little lakes. And Lee was just talking about this too, that probably lose those lakes. And now I want to talk about, projecting into the future with, I call it crystal balling sometimes, but, and I want to talk about this just for the floodplains at the moment. And I want to, talk about the relationship of permafrost in the future, basically just a 2060 scenario. Temperature warming, precipitation, fire frequency, and non-native plants. But there's a reason why we can understand succession, why we've done studies in forested areas, and it's because we can actually age the trees and and we can go back in time and just state what the forest is now compared to when it was burned, say 50 or 75 or 200, even 200 years ago. Whereas in shrublands, we don't have any way to age the shrublands, and we don't have any way to age the dwarf shrub areas. And so there aren't any really good successional studies. It's called chronic sequence studies. There aren't any really good chronic sequence studies in the dwarf shrublands or the low shrubs or the alder areas or even the willows up on the hillsides. And so really the only places we have successional information is in the forested regions and also down the floodplains, because you can actually age the trees. Now, there are some successional studies where we have old photos. They did that up on the North Slope, and they were able to look at photos from 75 years ago and compare them to today, just to see how things have changed. And just to be real brief, these are just Nancy's slides. It's predicted that, the blue is where the permafrost is, or discontinuous permafrost is right now, and here in 2060, it's going to mostly disappear in the REA. Temperatures are expected to warm up. Precip is expected to increase throughout the REA, and also fire frequency is expected to increase. So everything's going to increase. Permafrost is going to decrease, and temperature, precipitation, and fire are all going to increase. How am I doing on time? I've probably gone way over.
You need, 15 minutes.
Oh, I do.
We have it short. You started a little early.
Okay. And so just in real general overview of the response of vegetation on the floodplains, we're going to lose 29% of the permafrost is going to be lost from the floodplains, a reduction of 29%, quite a bit. And precip increase is going to be by 6%. But basically what we're thinking is we'll probably lose a lot of the black spruce and black spruce tussock tundra on the ancient terraces. Kenai birch will migrate up the river corridor and be more common, and in place of Populus balsamifera. And not that that's going to go away, but Kenai birch probably be more common. And we'll lose those thermokarst wetlands as the ice melts, permafrost melts, and the ice-rich soils melt from that area. And they'll subside, when they melt, they'll subside 6 feet common up on the floodplain terraces because they have very, very ice-rich soils up there. And again, this is just for floodplains. You know, if fire frequency increases, well, currently on the floodplains, fire frequency isn't very high because the streams tend to act as fire breaks. You know, these large channels tend to act as fire breaks, and also deciduous species don't tend to burn as frequently as black spruce, which burns very frequently, versus which isn't down there most of the time, and white spruce, which is flammable also. But anyway, we're expecting possibly a dramatic increase in fire frequency for the area, and so it might start affecting the floodplains at some point, burning these older growth forests, and because of the fire breaks down there, and these areas tend to be protected, they also tend to support, the floodplains tend to support the oldest spruce forests we have in interior Alaska, 400-year-old forests that just occur down there. And then non-native plants, Matt already covered this. You know, we could have an invasion of Prunus patus like we're having in this area, and also Melaleucas alba could expand, and probably is expanding down on the floodplains right now. I'm just going to talk about anthropogenically disturbed areas in the floodplains. Right now it's 1.6%, and it could go up to 5.6%, 5.6 anyway. Yeah, very precise numbers. But and a lot of this increase down in the floodplains would possibly be the Kuskokwim Road south of the Grass Pedal Mine, and then the Donlin Mine, and then there were quite a few other human disturbances that might occur in the future down there. But you know, right now most of it's just the villages that are down there, and you can see that the villages are also probably going to need to be moved. This one's on the inside of a graph, on the inside of a river curve, and it's just going to disappear probably in the next 100 years, that whole area. They're all down on the floodplain. Those floodplains migrate. Most of these floodplain sites are less than 200 years old. These floodplains migrate across the width of their of the active floodplain every 200 years or so, and starts everything over again. Here's just the landscape condition model. I showed this yesterday. It's kind of hard to see what's going on, but basically we're going to see you know, a slight increase in human impact down the floodplains. Now, insect and disease damage on the floodplains, all I'm giving here is the current impacts. I don't know what's going to happen in the future. I don't think anybody really can predict that. So we didn't project this into the future, but most of the impact is from the spruce bark beetle, and which was actually surprising me. I thought there'd be other insects that were hitting the vegetation hard out there, but evidently not. But when you do go and look at go down the floodplains and even some of the side slopes in that area, there is a lot of damage to the willows and alders, especially willows down the floodplains. But that damage is hard to see, you know, when state and private is flying around recording this information. If a willow dies or if alder dies, it's actually hard to see, and within 1 year, it's almost impossible to see once it's lost its leaves.
We'd just add that we do have maps also of other defoliators outside of just the spruce bark beetle.
Yeah.
So we have that mapped as well.
Wait, I'm sorry, this is Cindy. I was reading the legend here, and it says forest damage. I was just going to ask for clarification on whether the red area is really just the spruce bark beetle polygons out of forest damage inventories, or if this is total forest damage inventory.
This map is a total forest damage.
Okay.
The spruce beetle is the largest defoliator that state and private has mapped, and it's roughly 50% of the total forest damage, or 40%, something like that, Tim?
Yeah, it's probably something like that. It's mostly concentrated along the Yukon, Kuskokwim, and then, the southeast rounds where all the way, but, not everything on that map is spruce beetle.
Now we'll just look at all the conservation elements combined. In other words, we're just combining the white spruce and black spruce and all the CEs except for the floodplain. And I'll just quickly go through how the effects of permafrost loss, temperature warming, precipitation increase, and fire frequency in non-native plants affect all the CEs except what?
5 minutes.
5
Go through
minutes.
all this.
I'm going to blast through this, okay? You know, I covered this yesterday, so I'm going to,
That's right. Here, let's go.
Okay,
Keep
okay.
going. Ignore Monica.
So, basically, by 2025, it's predicted that only 1 to 3% of the entire area will lose permafrost, but by 2060s, it'll be 8 to 29% of the area will lose permafrost, and a lot of the response will be the same as I reported down on the floodplain, but you know, you're going to have we'll lose a lot of the black spruce woodlands, but we don't know what the response to tall shrubs, low shrubs, and herbaceous wetlands will be. Again, that's partly because we don't understand succession in those areas.
I'm sorry, can we go back to that slide for a second? The 8 to 29 of the CE will thaw, partially thaw, is that, the area that's turning from blue to white on the permafrost map is about 29% of the landscape? Is that what that number means? Is that?
29% of the, of the distribution of the CE, current distribution of the CE.
But this is all veg CE, so I would assume it's the
So
entire.
this is the range for
Well,
all
there's
the,
area.
this is the
Right.
range for the, thank you. So it's the range, and here the lowest is 8 for dwarf shrub, 8%.
Okay.
And the highest is actually, I do include floodplains, 29%.
Oh, I see.
So, I should slow down, huh? And we're also expecting the area to burn more frequently, and white spruce and black spruce become less common, and will probably convert over to more deciduous forests such as balsam pine and paper birch. We'll have less lichen, and again, we can't predict what's going to happen with the information we've provided so far in the tall shrub and low shrub, et cetera.
Tracy's going to talk more about lichen in your
Yes.
section. Okay.
Not very much, though, I really just have a quick slide, but we can have a discussion about lichens if you want to while I sit.
And the insect and disease and invasives are is basically the same as what I presented for the floodplain. So I'll skip that and go to the landscape condition model. Right now, it's only 2% for all the CEs combined, and at most, by 2060, it'll go up to 4% for the area. I want to go to applications and limitations. So applications of the results, the conceptual models, the vegetation map, and the successional information. These are all basic needs for identifying long-term monitoring plots. That's what we're using up on the North Slope right now with the BLM. You know, it's just the basic units we use for being able to identify where we're going to do our monitoring. Right now, the USGI, the National Wetlands Inventory with U.S. Fish and Wildlife Service is linking their wetlands map to our map, and so that product will be done in just a few months. So we'll be adding the entire National Wetlands Inventory map to the map that we have currently, and all crosswalks, and it should be nice and pretty. But you can use this information for developing successional maps too. Very importantly, modeling animal and plant species distribution. Landfire uses it for predicting fire behavior, and SNAP uses this type of last bullet here, I should have shortened these up, another thing is to identify, where these ACEs should be placed, or research natural areas, at least for vegetation. Unless you have a map, it's hard to identify, where critical habitat is, or where research natural areas should be, designated. And I know you guys have put out a call for that, at least in Western Lands, because the BLM has put out a call for, new, areas of critical environmental concern, the ACEs. So limitations and data gaps. And so for us to do our, climate projections, we really need to, and this is what we talked about earlier, we really need to model the distribution of black and white fruits, one way or another within our map in order to split that up. And that's, we should be able to do that, with the new, DEM that's coming out. And we should even, I think we should be able to do that for, peatlands, versus uplands, which is another critical, need within a vegetation map. But most of the other classes are, provide plenty of information for our needs, but splitting out black spruce and white spruce and understanding where the peatlands are is important. We needed a vegetation succession map. That's a typical step that's done once you come up with your existing vegetation map. The next step can be to develop your succession map. And, we've done that in large chunks of the state. Most of the national parks now have these, dual approaches, including a plan association classification, the third bullet. So most of the national parks right now have, a vegetation map. They have the vegetation succession map, which is basically a biophysical setting. And they also have a plan association classification. I should say about half the parks do.
So how are they doing that without a good quality DEM or any soil data or, any decent hydrologic data? How have they actually done that with any accuracy? Are they just getting that on the ground?
Yeah, we did all the ones that, we did. This is, well, I shouldn't say all of them. We didn't do it for, the low elevations in Glacier Bay. But once, when you're on the ground and stomping around out there, you get more of a feel of what's out there, and you can delineate where the floodplains are, where the tidal marshes are, et cetera. And so we went ahead and delineated those units. And so we developed a vegetation map and then, actually drew the lines. And the lines are no more accurate than the current StatCo, lines, because we used, Landsat. And, the NRCS lines are pretty good. They did a nice job. They did as good a job as they could with the information they had, and I guess that's the limitation of the same on our maps.
And StatCo's rough about 1/500,000, isn't it? Is the scale that's given to them?
Yeah, it depends on where you go. Sometimes they do a much better job. Some of the drainages, somebody sat down, they drew better lines than in other drainages, but in general, I think, I'm not even sure.
Well, the StatCo map is kind of statewide data, but then there's also, regional soil surveys, so some of those data are at finer scale. So depending on what you want to look at, if you need kind of statewide data, StatCo at a coarser scale, but that.
Surgo is the coarsest, it's the finer scale, right?
Yeah, and then there's the individual soil surveys that were done. But maybe you could also mention that we are developing biophysical settings for the North Slope REA and, not kind of based on this new vegetation map that was developed through the NSSI project. So it can be kind of done retrospectively after a vegetation map is made if you have good if the classes were developed well, and you have a good understanding of the landscape, and that's how we're kind of approaching it without having to do additional field work.
Yeah. And, up on the North Slope anyway, some of the areas we really don't know what succession is, the dwarf shrubs, up in that alpine area. And, we really can't define the biophysical settings all that well.
we can maybe map them, but we don't understand the processes within those units.
Yeah,
Yeah.
yeah, but, a lot of the areas we do understand succession, and we've mapped it, but, with the BLM, these biophysical settings, they're just the basic unit for identifying, where to set up their monitoring plots. My big additional recommendation is to go ahead and develop a new map, a new statewide map using new, spot imagery. What is it, 2.5 meter pixels?
Hand sharpened, 10-meter resolution.
10 meter.
For the multispectral, and then, you can sharpen it to get it better stuff, but 10 meters is a huge improvement.
Yep.
Landsat, same spectral range, spectral resolution, but still pretty good.
From the last I saw from Ann Johnson, the western interior has large gaps that won't be available for a long time.
Oh, really?
Couple of years, yeah.
Couple of years.
Oh, a couple of years, okay.
I think, I mean, they keep trying to go out and collect them new and, but it's sort of partially contingent on the DEM too coming out and everything.
Yeah.
Right. Is there a specific timeline for the new DEM yet?
I think they wanted it by 2017, is that kind of their target, do you remember?
Something like that.
Yeah, it just totally depends on, can they get the imagery, on the cloud-free days, so there's not scattering, can they get can they get all the information that they need? They've had some problems, and they're still securing funding and all that kind of good stuff, but the goal is 2017.
Core Black has a setup on the server at the state office to show, at least in our map, what's been done so far, what we have access to.
It's about a third of, about a third of the state has been done already, and we have access to that, you can get it together through